Alright guys, we are at the volleyball game tonight, so it might be a little noisy in here. I stepped out into the sack so that it's not quite as noisy. We only have 5 problems tonight on the 3-1B, and we're going to go through this fairly quickly because there's only 5 problems. Hopefully it doesn't get too noisy in here. If it does, I apologize. Alright, first problem. Alright, it's this thing, I had to move some stuff around trying to make a new slide, and it ended up not writing out the way I wanted it to. That's okay, we'll let it write out to the point that I want it, and then I'll stop it and we'll go from there. Okay, let's stop it right there. Alright, what we see for number 6, okay, this is the first one you've got to do. For number 6, it wants us to use a graphing calculator to find the linear model for the set of data that we've got here. We have the winning times for the Olympics in the 100-meter butterfly. That's a swimming event. Okay, I've got a bunch of pictures that I took for this one this time. First, I took a picture of our table. This gave our years from 1972 to 2008. Okay, and then it gave the male winning times and the female winning times. And as you can see, those times are gradually dropping. They want to know in what year will the two quantities be equal. So in what year will the women's and the men's winning time be the same? Okay. Now, I started by putting my numbers into my list. My years are my X's, so they're in L1. Then my male times are my Y1. These are my X's. This is my Y1. This is my Y2. Okay, so my women's times are my Y2. Okay? Now that I have everything into my list, I want to go and find my equations. Okay, remember that we use the stat calc 4 to get our equations, and I use L2 to get my Y1 equation up there in blue. I use my female times, my L3, my list 3, and remember we changed that. If you have one of the newer calculators, you can change that. When I do my stat calc 4 and I have the 5 lines, I go down to where it says something about the Y, and then you just change that. You do alpha 3, and that pulls up list 3 for you. Okay, but when I put that all in and I get my Y2, here's my equation for my Y2. Alright, now that I have my equations, I can go ahead. I want to graph this time, okay? Because this one's a pretty big graph. Okay? So let's first think about our window settings. Okay, now there's okay, I didn't want to go that far, but here's my Windows settings. Okay, now my minimum, okay, my times start in 1972, so I'm going to go back just a little bit to 1960. Okay, now here's what I did. I started out with 1960, and I thought I'll go 100 years. So I went 2060. When I went 2060, there was no crossing. I had not gotten to the point. So I went out to 2160. 2160, I still couldn't see any crossing. So I went ahead and went out to 2260 to see exactly where my lines were going to end up crossing. That ended up working for me. Okay, my scale for my X's is 10. So there's 10 years between every little tick mark there. All right, for my Y's, I started out as a minimum time of 0. He's not going anywhere. Okay, and then Y max, my female time had been 63.34 seconds. So I went just a little bit higher than that so I could see the beginnings of our graph. And for my Y scale, I went ahead and did increments of 5. Okay, so that's this slide. Okay, I went ahead and went into my Y equals. Okay, and I inserted my Y1 equation and my Y2 equation. When I graphed it, here we go. I finally see that crisscross that I'm looking for. Okay, so I went and I did second, trace, 5, and that brought up the blinking cursors, and then I do enter 3 times. Because the first 2 times you're identifying your line, and the third time you're asking it to figure out where the intersection is. Okay, and then we ended up seeing that right there. It gave us that blinking cursor. And so at that blinking cursor, that was the year 2168 and 3/4. So that was probably about September that year is what they're figuring. But in 2168, they anticipate that we could have men and women winning the 100 freestyle butterfly in a time of 32.45 seconds. All right, let's go to the next. Okay. Filling in. All right, getting us some writing space here. Okay. Now, it says, without graphing, does each system have 0, 1, or infinite many solutions? To start, write each equation in slope-intercept form. So that's what I'm going to do. With number 7, I'm going to take y1, which is my first equation. 4y plus 8 equals 12. We're going to subtract the 8. We have 4y is 12x minus 8. I divide by 4. And I have y is equal to 3x minus 2. Okay, y2 is my second equation. Y minus 5 is equal to 3x. I'm just going to move my 5 over by adding it to both sides. And I have y is 3x plus 5. Now, I'm going to look at my equations, and I'm going to look at my slopes. Both my slopes are 3. Okay? Then I look at my y-intercepts. I have a -2 and a +5. So I have same slopes, different intercepts. That gives me, you got it, parallel lines. Okay, parallel lines have no solution. All right, number 8. y1 is 6y minus 3x is 12. So we add 3x from both sides. 6y is equal to 3x plus 12. I'm going to divide by 6. And I have y is equal to 1/2 x plus 2. y2. 2y is equal to x plus 4. I'm going to divide by 2. And I have y is equal to 1/2 x plus 2. I look at my equations, look at my slope and my intercept. It's the same in both. So I have coinciding lines on this one. And that means I have an infinite number of solutions. Alright, number 9. First is 1/5 y equals x minus 1/5. I'm going to multiply both sides by 5 so that I can get rid of these 1/5. So I end up with y is equal to 5x minus 1. Okay, I look at my y2 and I subtract my x, add my y to both sides. I end up with y is equal to negative x plus 11. Looking at my equations, I look at my slopes. I have different slopes. That means I will have an intersecting line, a set of lines. That means they'll intersect at one point. So I have one solution. All right. Last problem. All right, get this to where we've got some writing surface here. Okay, and it says, your business needs to ship a package to another store. Company A charges $2.50 per pound plus a $20 service charge. Company B charges a $4.50 per pound charge without any service charge. At what weight does it cost the same for both companies? And then B, if your package weighs 14 pounds, which shipping company should your business use? Alrighty, let's take a look. Y1 is company A. So that is 2.5 times x plus 20 is our cost. Y2 is company B, which charges $4.5 per pound, no fee. We're going to need two charts, X, Y1, and Y2 on both. Alright, I put that into my calculator, into the Y1 and Y2, and then I pull up my table. As I scroll through my table, I finally see that at 10 pounds, my Y1 and Y2 are both the same. So I'm going to put down my numbers above and below just to show that yes, I did do the work, even if it was in the calculator. Alrighty, so this was A, and the weight it costs the same for both companies is 10 pounds. Let's do this. Okay, 10 pounds. Okay, all right. Then it says, if your package weighs 14 pounds, which shipping company should you use? So I look at where I have 14 for my X, and I have Y1 is 55 and Y2 is 63. Okay, and I put my numbers above and below, and I look, and at 14 pounds, $55 is less than 63. So I would say use company A. All right, guys. That is it. That's all the homework for tonight. If you're watching this and you're in the advanced classes, I will get a video out at some point in time. Right now, I'm going to take a break because sitting in those stands is killing me. But at least we've got one video out for now. I'm going to go ahead and wrap it up. Y'all have a great night. I'll see you in the morning. Be ready for a homework quiz.